Hello. In the previous class, we understood the classification of signals into even and odd. And I also mentioned that there are some signals which can neither be even nor be odd. However, any given signal can be decomposed into the even portion of the signal and the odd portion of the signal. So in this class, let us see how we can decompose a given signal into the even portion and the odd portion. So let us discuss how we can decompose a given signal into its even portion and odd portion. So as I mentioned, any signal except t will have even portion and its odd portion. So suppose if I just replace t by minus t, so this will be equal to, since for an even signal xc of minus t is c of t and x naught of minus t is minus x naught of t. So we have two equations, equation 1 and equation 2, which relate the signal x of t and x of minus t. Now if I add 1 and 2, add equation 1 and equation 2, so what I get is on the left hand side x of t plus x of minus t, on the right hand side plus x naught of t and minus x naught of t cancels, so I will get 2 times xc of t. Therefore I can now write c of t as x of t plus x of minus t divided by 2. So this equation can be used to determine the even portion of the signal. Suppose if I subtract equation 2 from equation 1, then on the left hand side I will have x of t minus of x of minus t. On the right hand side, as you can observe here, xc of t minus of xc of t cancels, so I will get 2 times x naught of t. Therefore, the odd portion of the signal x naught of t can be expressed by using the equation x of t minus of x of minus t divided by 2. So this equation can be used to determine the odd portion of the signal. So if whenever a signal is given, we can now decompose into its even portion by using this equation and odd portion by using this equation. So this is how we can determine the even and odd portion of a given signal. So let us take a simple example to illustrate this. Let me just take a simple example. Say x of t is cos t plus sin t plus sin t cos t. So to find the even portion, what we need is x of minus t. So let me just replace t by minus t. So cos of minus t plus sine of minus t plus sine of minus t into cos of minus t. So as you know, cos of minus theta is cos theta, so this is cos t. Sine of minus theta is minus of sine theta, so this is minus of sine t minus sine t cos t. So now I can use the equation for finding even part of the signal. I need to add x of t with x of minus t divided by 2. So we just add x of t with x of minus t. You can see plus sine t cancels with minus sine t plus sine t cos t cancels with minus sine t cos t. So what I get is cos t 2 cos t divided by 2. So this will be equal to cos t. Similarly, I can find the odd portion of the signal by subtracting. So it is x of t minus x of minus t divided by 2. So if I do that, what you will have is okay, so cos t cancels with cos t, sin t minus of minus sin t is 2 sin t, and sin t cos t minus of minus sin t cos t will be 2 sin t cos t divided by 2. So the odd portion is sin t plus sin t cos t. So you can see that if I add odd portion with the even portion, I'll get back original signal x of t. So x of t is xe of t plus x naught of t. So this is how I can determine the even portion and the odd portion of a given signal. Okay. So similarly, we can also solve one more problem. So you can just take it as homework. Say x of t is 1 plus t plus 3t square plus 5t cube plus 9t to the power of 4. So what is its even portion? What is the odd portion? Okay, so this can be verified by following the same steps. And I also want to give you a homework. Okay, there is a concept called conjugate symmetric, which is defined for complex signals. So I want all of you to look into this concept and understand what do we mean by conjugate symmetry. So this is how we can decompose a given signal into odd signal and even signal. So the classification of signal can be even or odd, or it can be neither. When it is neither, there is always a possibility that you can decompose the signal into its odd portion and even portion. So with this, we will complete the second classification. In the next class, we will discuss one more classification, that is periodic and non-periodic signals. Okay.